Hi, good day. So in our past discussion, we learned the mathematical concept behind the p-scales. We learned that p-scale is just the negative logarithm or the decimal cologarithm of the thing that it describes. Also, we learned that pH is associated to hydronium ion or hydrogen ion concentration. POH is associated to hydroxide ion concentration. pKa is associated to the dissociation constant for acid, and pKb is associated to the dissociation constant for base. And with those, we learned that pH is equivalent to the negative logarithm or the decimal cologarithm of the hydronium ion concentration. POH is equal to negative logarithm of the hydroxide ion concentration. pKa is equal to negative logarithm of the dissociation constant for acid, and pKb is equal to the negative logarithm of the dissociation constant for base. But what if, for example, the pH is given and we are required to find the hydronium ion concentration? The POH is given and we are required to find the hydroxide ion concentration. The pKa is given and we are required to find the dissociation constant for acid. The pKb is given and we are required to find the dissociation constant for base. For those instances, what we are going to do is we are just going to reverse what we did on our p-scale. If in our p-scale, we just get the decimal cologarithm or the negative logarithm of the thing that we actually describe, what we are going to do here is just reverse the logarithm, and the reverse of logarithm is known as the anti-logarithm. Okay, so anti-logarithm is just equivalent to 10 raised to the negative p scale. Take note ha, 10 raised to the negative p scale. And because we have here 4 different p scales, then we could also have here 4 different anti-logarithms of these p scales. So we have here the hydronium ion concentration is equal to the 10 anti-logarithm of the negative pH. Okay, hydroxide ion concentration is equal to 10 raised to the negative POH. Ka, or the dissociation constant for acid, is equal to the anti-logarithm of the negative pKa, and Kb is equal to the anti-logarithm or 10 raised to the negative pKb. Okay, now take note that you cannot use the value for pKa to find the hydronium ion concentration. Okay, so again, it's H3O to pH, OH to POH, Ka to pKa, and Kb to pKb. Okay, now let's give here an example of problem where we can actually use this formula for us to be able to find the hydronium ion concentration, hydroxide ion concentration, Ka, the dissociation constant for acid, and the dissociation constant for base. So let's have here this problem. Find the pH, pKb, hydronium ion concentration, hydroxide ion concentration, Ka, and Kb if POH are given here is POH, if POH is 2.3 and pKa is equal to 10.5. So obviously we have here two given values, the POH which is 2.3 and the pKa which is 10.5. Okay, so the first thing that we need to find here is the pH followed by the pKb. Okay, so for the pH, we cannot really directly use this formula to find the pH. Okay, why? Because we don't have hydronium ion concentration here. In fact, hydronium ion concentration is one of the things that we need to find. Okay, so instead, we can actually use, since we have here POH, we can actually use this formula. Remember that when we add pH and POH, that is always equivalent to 14. So we can use this formula to find our pH. So pH plus POH is equal to 14. pH plus 2.3, which is our POH here, is equal to 14. By transposition, then we can have here pH is equal to 14 minus 2.3. So from positive, it became negative because we transposed the value. And pH is equal to 11.7. Okay? Now, for the pKb, still we cannot use this formula, because we don't have the given for Kb or the dissociation constant for base. But we have pKa here. Okay, and we know that pKa plus pKb is equal to 14. So we can actually use this formula to find our pKb, given our pKa. So pKa plus pKb is equal to 14. pKb is actually our missing here, is equal to 14 minus 10.5. We transpose the value for pKa here. Okay, so it became negative 10.5. So 14 minus 10.5 is 3.5. That is now the value of our pKb. Okay, now because we now have here the value for pH, then we can now solve our hydronium ion concentration. So again, in our formula earlier, to find the hydronium ion concentration, we just need to get the anti-logarithm of the negative pH. Since we now have here the pH, then that is equivalent to 10 raised to the negative pH. That's 10 raised, or the anti-logarithm of the negative 11.7, okay, which is actually our pH. And therefore, if we are going to do this in our calculator, the answer will be 2.00 times 10 raised to the negative 12 molar. Take note of our unit here. Our unit here is molar because we are asked to find the molar concentration of hydronium ion. Okay, so molar. Okay. How about for the hydroxide ion concentration? For the hydroxide ion concentration, since we have here POH and we can actually use this formula, okay, then we can directly solve our hydroxide ion concentration here. So for the hydroxide ion concentration, that's equivalent to the anti-logarithm, or 10 raised to the negative POH. Okay. We have here 10 raised to the negative POH, 10 raised to the negative 2.3 because that is our POH here. And the hydroxide ion concentration is 5.01 times 10 raised to negative 3 molar. Just for you to see how we arrived at this answer, 10 raised to, okay, negative POH, which is negative 2.3. Okay, and we will have here, okay, 5.01 times 10 raised to negative 3. Okay. Next, for the Ka, since we have here the value for pKa, then we can actually use this formula. Ka is equal to 10 raised to negative pKa. So that's 10. Our pKa is 10.5. So that will become negative 10.5. So that's 10. Okay, 10 raised to negative 10.5. Okay, can you see it? Okay, and our answer will be 3.16 times 10 raised to negative 11. And finally, we have here the Kb. Kb is equal to Kb is equal to 10 raised to negative pKb. Okay, and Kb is equal to 10 raised to negative 3.5. Okay, because our value for Kb here, pKb is 3.5, so that will become negative 3.5 here. Okay, and Kb is equal to 3.16 times 10 raised to negative 4 if we do this one in calculator. So that is how you can find the hydronium ion concentration, hydroxide ion concentration, Ka and Kb given our P scales. Okay, so that's all. Thank you for listening and good day.